Dang, Chris, I should have stayed back for the cookie.
Exactly. Only we'd known.
Had I known Warren was going to bring cookies.
All right. I think when cookie time is done, we're ready to get started. And I believe Warren is running the presentation, so I won't do any of the presentation stuff.
Stop the thing. IETF 113. So I'm doing the slides, we said? The driving of
Yes.
the thing. Okay. Just waiting for the thing to reload. And Sidrops. I'm assuming that the first set of slides that you would like presented is going to be the chair's ones, because that seems to make sense. I just realized that I've always done this being not in the chair role, so...
Warren, you are not audible.
Oh. Really? I thought I was audible.
Locally, yes, but not high on the mic. We got link local connectivity only. V6.
You know,
That V6 is your calling.
double clicking? No. Does it locally? Not in the presenting. Oh, did you click? Share. Yeah. Share. Yeah. Does this forward and back work? Let me check if my forward and back works. It does not. But that clicky does. Alrighty, the slides are loaded. I don't know if you're going to do the intro or...
I can, yeah. Okay, so we're getting started. We have a relatively full agenda. This is Sidrops at IETF 113. Either you're in the room and you're in the right room, or you're virtually on the Medico, in which case you made it to the right room virtually. If you think you're not in Sidrops, you should go to the other room. But you could also stay and listen. I'm Chris. Kayer is on virtual thing too. Natalie's at the desk with Warren, who's running all the slides for us. And John Scudder says perhaps the in-room chairs need to make sure they're very close to the mic. Okay, next
Does
slide.
that work?
Actually, let me also check the room mics because the batteries keep dying.
Okay.
Great.
Okay. The next slide is the note well. People can download. I should have said all of the slide decks we have should be in the meeting materials site appropriately. I think there's one update to the chair slides to put in, but we'll do that at the end of the meeting. Medico says they had to lower the front mic because of feedback. Oh, good. Okay. I think we don't really have any agenda bashing to do. We do have a short chat from Allison Mencken, the IETF ombudsman, who wants to come and talk to us about code of conduct and how we should be paying attention to whether the code of conduct says instead of not paying attention, which we have a tendency to do. So, Allison?
Yeah, Yo from the Ombuds team. That was the Yo from Beowulf. So we've had a bad season this season with Sidrops. I'm authorized to say we're normally extremely careful about confidentiality, but I wanted to say that we've agreed to let you know that we've had quite a few cases of people who feel concerned and uncomfortable with the kind of discussions that go on in Sidrops. And the ticket to doing the right thing here is to just come back to the code of conduct over and over again, which says be neutral, be equal, be respectful to each other. If you are saying something about somebody using the word you're probably doing it wrong. And understand that the problems that you're solving are very difficult. So it has to be, there's a need for more respect and more care in disagreeing because the disagreements may be complex. But the problems that have come up from the ombuds team that we've seen have been both problems of long people that are well established and you would expect to be comfortable and know how to deal with problems, but also problems of people who are new and not well established and are not sure that they can participate because they don't know how to work in the environment. So we wanted to make it clear that without paying enough attention to the code of conduct, it's probably very difficult to solve the problems that you have, which are really difficult problems. It's also probably difficult to get new people involved who may have solutions that you haven't thought of. So this is my pitch. And I'd like, we were invited by the AD, by Warren, to come and speak to you. And I've spoken several times now with the chairs about this too, to go back and reread the code of conduct. If you have any doubts about something you're writing in an email, go back and reread the code of conduct. If somebody objects to something you say, please think about your code of conduct and pull back from the way you've said it. Please try to lessen our caseload from Sidrops. So I can't really answer any questions because of the confidentiality, but that's the message. And I think Warren or the chairs may want to add something, but if not, that's the pitch. Warren, anything you want to add?
Yep, I'd like to add something. Yeah, I mean, I must admit that, well, let me turn my volume off here. Yeah, I've never had code of conduct discussions with the ombuds team and any of my other working groups. So, you know, I would like to continue not having code of conduct discussions with the ombuds team. I'm really glad that people are passionate about this stuff. And we have some strong personalities. Just sometimes the passion kind of overflows from let's make this thing better into like, let's beat up the other. And one of the things which I think is happening is in many cases, a lot of the people participating know the other people and think that they understand how their message will be heard. And even if that's true, people who aren't in that discussion see the sort of sniping and get concerned that they might also be attacked if they start participating. So, you know, while Chris and I can call each other, you know, I can call Chris's mommy fat and he can say I'm ugly, and we're both okay with that, especially if you've seen his mama, it drives other people away. And so, you know, we need to keep that sort of thing in mind. My God, I'm glad that I'm not in Reston, you know, where Chris is, because when I get back, there's going to be a beatdown, I'm sure. But yeah, I mean, really, we need to be a lot more careful with this. If you're writing a reply, both think about, you know, whether it's technically accurate and also whether you could word it in a way that comes off slightly less, you know, aggressive jackassery.
Actually, so Warren, not slightly less. So let's try not to pull our punches too much. Don't be aggressive. Be only as aggressive as necessary. Only as strong as necessary, not aggressive. And I know that some people will disagree with that, but the problem solving, the judgment about how aggressive has been over the top for a while now. So I'd like us to let the strong personality say, you've been aggressive in ways that are, you know, too much of your mama's fat, and now we have to have none of that now. Let's pull back further than you expect you need to. And I think you'll find, and I think the chairs will find, that this will make for the working group to go better. I hope that's true. Okay.
Yep. Yeah, sorry, that's what I was trying to say.
Yeah.
And also, you know, we should, if you are disagreeing with something, it should be the idea that you're disagreeing with, not the person.
Yeah.
If you're disagreeing with sort of the person or the person's personality, you've already lost the argument. But yep, we have Lars in the queue. So Lars, go ahead. Oh, there you are in person.
Lars Lehmann from NetNode. I would like to add one other recommendation that has saved myself a couple of times, and that is when you feel upset about something that someone has written and you write an answer, do that, but don't send it. Let it sit there
Yeah.
for a couple of hours. Go back, have a cup of coffee, read it again, and you may find that you may want to change a few words here and there and change the entire tone of the message. That has helped me every time I've broken that broken that rule. I've had to back up and apologize and felt miserable about it. And every time I've followed the rule, I've been very glad afterwards. So at least make the attempt.
Yeah. Also, if the main discussions are between 2 or 3 people, and there is more than 2 or 3 emails in a day, you might want to sort of stop and take a step back and be like, is this really the discussion we should be having now? If it's, you're missing a comma, it might be better if you had a dash here. That's great. If it's your idea is the worst one I've ever seen, that's not. Okay, I think we've all got this all understand what's going on. And also thank you very much, Alison and the Ombuds team for, coming along and doing this. And also apologies to everyone that this was needed. And
Okay, I'm
With
gonna
that-
go, but I wish you everybody luck, and I'm gonna we'll be continuing to monitor the cases. So please do us a favor and keep reading the code of conduct and thinking about how to be good to each other. Thank you.
And also, if anybody is feeling stressed or, attacked or something, I will admit I don't always keep up with all the mail. Feel free to mention it to the chairs and feel free to mention it to me. If stuff's not going well, just speak up and let's get this under control. And I believe that the first set is Mr. Yob with a long title, which Nathalie will read out because I'm trying to find the slide.
Update on resource sign checklist and RPKI client.
Which slide deck is that?
The second one, I think. Maybe
Well, Meet Echo decided to just close the tab at me.
oh no.
I don't know if you want to start introducing yourself, just in case somebody doesn't know who you are.
My name is Job Snyders. I work for Fastly, contribute to OpenBSD. In the last 2 years, I started running, hiking, Kung Fu.
I'm waiting for Data Tracker to load. The tab closed itself, which was awesome.
Did you try disabling IPv6?
Yours. No, actually, I'm not, luckily, because I would have felt like an idiot if I were. Rejoining. Request browser permissions. Complete. Click share slides. I only see sign till verification.
How is that even possible?
I will have to share from my thing instead, from my tab. Sorry that this is all taking a while. Luckily, that's in no way embarrassing, like we've never used a computer before. Do you want to share my screen?
Oh no.
Why not try? What was wrong with slide sharing the pre-uploaded ones?
They are pre-uploaded, but for some reason my
Not
machine
appearing.
has decided to not show them again.
They are.
So-
They are in the meeting materials. They all are, but they don't show up in the chair toolie thingy.
Do they show up for you in the Meet Echo view?
Only 4 show up for me.
Meet Echo folk, would you mind doing the magic to make the pre-uploaded slides populate into the share thing again if you're on the thing? They are in the chat. And of course, my browser had also updated.
Warren, I can see them.
Pardon?
I said I can see them.
Now they've all populated. They have now populated it in the thing.
Yeah.
So which set was
Super.
it? The name?
RSC.
RSC?
There you go.
Goodness me, that took a while. Apologies.
All right.
I have a timer as well.
How much time do I have?
10.
Perfect. Resource science checklists. This is work together with Ben Madison and Tom Harrison, and there are many other contributors that helped us develop the current specification. Next slide, please. So what is an RSC? RSC is an idea that is essentially a conceptual successor to an earlier idea called RTA, but it is a simplification of RTA. You can find references in the draft to the prior work. What RSC offers us is the means to use the RPKI to sign arbitrary digital objects in the form of a hash. You can sign so-called with resources. RSCs are distributed outside of the RPKI publication system, so their existence does not in any way impede the current ecosystem used for routing objects. And they could be useful in bring your own IP address or bring your own AS scenarios in context of, for instance, PeeringDB or cloud providers. You have to imagine that the likes of, say, Fastly or Amazon, when there's a bring your own IP request, that indeed it's useful to have the resource holder create a ROA, but the web user signing up to us, we don't know if they were actually the ones that created the ROA. And we don't really care who they are, but we do care if they are able to sign with the appropriate private keys. The current running code state is there's multiple implementations. There's 2 signers, one created by Ben Madison, one created by Tom Harrison. And on the validation side, there also is multiple implementations that demonstrate how these objects are to be decoded and validated. Next slide, please. The last update on this was at IETF 111. We, through the IANA early allocation procedure, received a code point to foster interoperability testing. By now, that code point has been renewed, and the code point has been added to OpenSSL 3.0, which is, has been released a few months ago. And starting in LibreSSL 3.4.0, the code point is also available. But these code points in the cryptographic libraries are nice, but all RP implementations know that they also have to declare the code points in their own RP software, because you cannot rely on the library being new enough to support code points like this, unfortunately. Next slide, please. The RSC files have the .sig extension, SIG short for signature. There's example files available on GitHub that you can use for testing your own encoder or decoder. This should be fairly straightforward, as RSC files are sort of a mixture between the RFC 3779 extension as it exists in the CA certificates, and you can take some inspiration from manifest handling. So if you glue those two together, you easily end up with an RSC capable parser. Next slide, please. This document would be really nice if other interested parties contribute. The expectation of the implementation report is that per normative term in the draft, people indicate whether they implemented it or not, and if not, why not. So the why not could be that you wrote a signer implementation, which doesn't concern itself with actual validation. So it's all very context dependent on which of these fields you'd implement, what values you'd fill in this table. But the The advantage of filling in reports like these is that we get a good understanding of whether all normative terms in a certain document are covered by at least 2 implementations, which means that 2 individual human beings were able to decipher the internet draft and convert it into code. And this greatly helps with the Shepherd write-up and also the IESG review in subsequent steps. So if you're interested to work on RSC, please also take a look at this wiki page and fill it in as you deem fit. Sorry. Yeah, next slide. The request to the big 5, the likes of Aaron, APNIC, RIPE, Afrinic, LACNIC, is to consider implementing RSC support in the hosted environments, in the RPKI dashboard or web portal or whatever you call it exactly. All of the RERs have different user interfaces, which I consider a positive thing because that is a good indication of diversity and allows us to learn from each other. So in yellow is an example that maybe is applicable in context of Aaron's email interface. And the lower right could be a web form where you, for instance, fill in the resource with which you want to sign, the hashes over which you want to generate the signature, optionally a file name, and the validity period of the RSC. And then what you should get back out of the system is a .sig file that you then can either email or upload through a web form or put on a USB stick or whatever the transportation means are. Transportation happens outside the global repository system. And of course, you should make a tool to revoke the EE cert in the RSC so that if any future point in time you want to withdraw the attestation, there's an ability to do so. Next slide, please. The spec has been stable for quite some time. Between version 5 and version 6, we essentially only bumped the version. I think there's sufficient running code to see that it works and is implementable. So with that, I would actually want to wrap this project up and request working group last call. And we have 2 minutes left for questions, comments. So with that, I hand it back to the circus master.
Jeff.
Yo, with quick operational question, since I haven't been following this. I think this is a wonderful idea. I don't operate one of the caches that collect all this stuff and do all the nasty crypto to verify it. Is there any long-term concern about adding a large number of objects to the RPKI system and impacts on the various applications that use it?
Jeff, thank you for the question. It is very important to note that RSC files are distributed outside the global RPKI repository system. To illustrate what that means exactly, ROAs, route origin authorizations, or CRLs, or manifest files are distributed inside the global repository system. So if you use rsync or RRDP, those are the files you pull into the system. But RSC files are not distributed through that means. They are distributed in a one-to-one fashion. So I could generate an RSC file, email it to you, and the global participants in this ecosystem would never ever know that I generated one and send it to you. So there is no burden on the global system.
That answers my question. Thank you.
Thank you. And I'm next in the queue. What would be helpful is at some point somebody explains to me the relationship between this and Sidrops RPKI has no identity. It feels like they're closely related. I'm going to have to explain it when it goes to ISG eval. And Rudiger will do your question, but then we'll cut the queue right after.
Yeah. Wait, you want to answer the question?
no, do that.
Oh, okay.
Somebody can explain afterwards.
I mean, if you want to take over my
You
job,
will
that's
be, you
fine.
will be shorter.
The relationship has been noted in the RSC draft itself. The RSC draft references the no identity draft, and the RSC draft explains that RSC files cannot be used to confirm identity. All it does is it confirms that somebody has possession of the private keys and the resources with which they signed are subordinate to the certificate authority.
Okay.
So from my perspective, there is no conflict whatsoever. I think everybody is on the same page,
cool.
and it's explained in the draft itself.
Very short.
Yeah. Referencing back to Jeff's question about what is the load on the general distribution mechanism, I was surprised by your request for revocation tools, which quite obviously will have a need on the distribution system, and but that's actually a surprising point.
Yes, the only load on the global system is if you revoke an RSC, the serial is appended to the CRL of that CA. So per RSC that you're revoking, you're adding a few bytes to a CRL. But then again, the RSC files could be short-lived, where you don't want to revoke. This is something we'll have to figure out in the wild. This is a tool. We're putting it in the toolbox, and we'll see how it works out.
Okay, thank you. And we are close on time, so let's get on to the next one, which might also have been, what's the file name for this one? Is
DOA, Discard Origin Authorization.
Yep. And I will put you down for 9 minutes, even though we said 10, because we wasted the first bit with me losing things.
Okay, I'll try to be
So,
quick.
thank you, sir.
Nee,
That's the wrong one.
Let's not miss slides. Anyway, I'm Ben Madison. I work for Work Online Communications. And hopefully we'll have slides soon.
Do it.
You can see it?
What it- We've just discovered it'd be useful to have the title, not just the file name and the file share.
Anyway, so DOA was the acronym that we came up with before we had quite agreed on what DOA stood for. So that is still subject to change. But this is another piece of work between myself, Job, and Mikhail, who's not here today, although maybe online. Next slide, please. So a very brief bit of background in case anyone is unfamiliar with the practice. Out in the wild of the internet, in order to try and mitigate the effect of distributed DOS attacks, it's fairly common practice for operators to need to ask someone closer to the source of the attack to discard traffic on their behalf, because otherwise, by the time it's on net for them, it's already overwhelmed links or devices on the path. And generally, this is done by adding a special purpose BGP community to a BGP announcement, and that community signals a request for the recipient of that route to drop the match traffic on the floor rather than forward it towards the announcer of the prefix. And this mechanism is the thing that we're trying to make a little bit more robust and secure through the use of DOAs. Next slide, please, Warren. Okay, so today, as I say, there's this fairly common practice that's been around for a while, which is interdomain RTBH signaling. And over the last maybe 3-4 years or so, it's become increasingly common for operators to run policies which involve dropping anything that has a ROV validation status of invalid on the floor at every ingress to their BGP topology. And these don't play nicely. Next slide. The fundamental problem is that by announcing an RTBH route for a victim of a DDoS attack, you're essentially completing the attack for the attacker. You know, you are killing off the victim in order to mitigate collateral damage. And as a result, you want to keep as much granularity in that approach as possible. And so usually these RTBH routes take the form of host length prefixes. Now, origin validation, on the other hand, has this concept of protecting against two types of misorigination. The first and most obvious being the wrong AS number doing the origination. The second, and often more useful, being preventing prefixes longer than some upper bound from being announced on the open internet. And there's a conflict here, because in order to have host length or very long prefixes propagate throughout the internet, one would need to create rowers that permit very long prefixes to receive a valid status. But in so doing, you effectively remove that second type of protection that ROV gives you, because you're essentially opening the door for any sub-prefix hijack to occur for any address space for which you want to be able to use this mechanism. The two common workarounds for this that exist today, some people force users of this kind of a service to create rows with those very long max length values, which essentially turns off that second type of check and is not a good idea. Secondly, and this is what probably the majority of people do, is they have a kind of a carve out at the beginning of their routing policy, which says, if this is carrying the RTBH signal, then I'm going to exempt it from the origin validation related policy upfront. Next, please. As I say, the first approach is problematic because it really breaks one of the fundamental things that origin validation gives you, and if anyone is doing that today, then I would suggest that they stop as soon as possible. Next, please. The second is, as I say, the kind of the lesser of two evils today, but it's really quite problematic. Firstly, the fallout from abuse of an RTBH signaling service can be quite severe. Especially where I sit in the topology as a transit provider, my customers are very often competitors of one another, and there is a very straightforward path to one customer black holing the prefixes of another customer using this kind of mechanism, which is almost impossible for me to defend against today without a mechanism like this. Next, please. And there's other kind of, side issues as well. Whereas a rower has meaning in a global kind of default free zone wide scope, RTBH signals are typically used very locally. You're not expecting to advertise one of these host length black hole routes and have everyone on the internet starting to drop traffic. The intention is that at most that signal is intended to propagate 1 or 2 AS hops away from you. And rowers simply don't mean that and have no way of communicating that kind of a scoping. The other problem is that we have no either implemented or even proposed mechanism to provide secure attribution of who's added a community to a route. So in a situation where the origin is more than 1 hop away from you, it's entirely unclear as a receiver whether it was the origin or their transit or their transit's transit that decided this traffic should be falling on the floor. And that has substantial contractual implications, as you can imagine. And this is that first point is made a little harder actually, because there's a well-known community that's defined in 7999, which is a value that anybody can use to indicate this these semantics without having to carve out a special community from their namespace. But what the old practice before this came along gave you was at least some indication of who the origin is trying to talk to. Because if they're using a community that I've allocated from my namespace, then I can interpret that as it being a request to me. Whereas if there's this general purpose signal, then it's difficult to know out if it's propagating kind of beyond the neighborhood of the origin. It's difficult to know who should listen to that.
And just to note, you've only got around 2 minutes. So
Okay, sorry, I'll try and speed up. Okay, so the idea is essentially to follow most of the logic that exists today in origin validation, but to add some heuristics to the object that we create that allows for receivers to know whether or not they should act on it. Let me skip forward maybe one in the interest of time. It's a 6488 style signed object, very similar in structure to a rower. It follows the rower procedure of the prefix holder signing the signed data in the CMS. And the distribution mechanism is very similar as well. It will require an extension to RTR, and it will be validated and processed on an RP, and that RP will be responsible for sending data to the router for use in routing policies. Next, please. This is what the content looks like. Next. There's a version field. Next. The IP address blocks is subtly different to what you find in a rower. Instead of having prefix and max length, you have prefix and length range. Reason being, as I say, you probably only want. Sorry, just a minute. You don't want, if your prefix is a 16, you may want to accept RTBH routes for a 31 and a 32, but probably not everything in the middle. So you have a range. The origin ASID has exactly the same semantics as it does in a rower. Next, please. The peer ASIDs is there to provide that idea of scoping. So only if you have received the actual BGP announcement from one of the AS numbers listed in peer ASIDs, you expect it to act on it. Next. And finally, there's a set of communities that the receiver of a BGP announcement can cross-reference against. And that tells the receiver whether what they think is an RTBH signal community is in fact being intended that way by the originator of the route. Now, I use the term heuristics rather than, rather than kind of specific criteria, because none of this gives you absolute certainty that this path that you're seeing in BGP absolutely is a black hole route. We don't have the mechanics to do that today, either in BGP or in the RPKI, but it gives you a very, very much stronger hint than today's mechanisms do. And at its very worst, it is at least as good as rower coverage for the equivalent unicast prefixes are. So it's not a perfect solution, but I don't believe that we have a perfect solution available to us today. Next, please.
you're going to have to go faster.
Yep. I'm going to skip over BGP route processing because otherwise that's going to take a while. But the general idea is that you have a parallel status which mirrors in some way the origin validation status, but the two are orthogonal to each other. So it's entirely legitimate to have a route that fails to match a DOA but matches a row, in which case it's probably a unicast route, and the reverse is true as well. Being origin validation invalid and being a match for a DOA probably means that it's a host length RTBH route. And so the idea is that those can be ships in the night. And as long as you are looking at the DOA status before the origin validation status, you can implement the same kind of check if it's an RTBH route up front before you look at the origin validation status logic, just like operators are doing today. So it's a fairly easy drop into current policies. Next, please. This is kind of what I'm describing there, where you're checking the DOA state up front and using it as a black hole route if it matches, and only then you're going on to your normal kind of unicast routing policy checks. Next, please. So this is fairly early stages still. I think the idea is mostly fairly well formed. I don't think that there's likely to be much change to the underlying idea. The document itself needs a fair amount of work. One of the questions that we had for the working group is whether we think that this should stay as one document or whether it should be split out into parts, kind of like the origin validation series was, where we define the object itself in one document, the validation process in another, and the RTR extensions in another still. I'm not sure I have a strong opinion on that, so I'm hoping for some feedback there. And I'd also like to know from the working group whether we think that this is a good candidate for adoption at this stage, or whether the working group would like to see it mature more as an individual draft and then talk about it sometime down the line.
Okay, so we have Jeff in the queue, and if you can keep your answer short, thanks.
Yes. So I have not read your draft. My question to you is this intended to address RTBH for anything adjacent AS?
So that's the purpose of the peer AS IDs field. The default behavior is that this will not allow transit for RTBH routes. But if you add one of your transit providers to that list of peer AS IDs, that's a signal to the receiver that you have authorized that transit, and that it should be matched and accepted. So that is supported.
Okay, thank you.
Do we remember what his slide deck's called? We're just looking for Ignis. I think you're up, and we're just looking for what your
Something, something. Yes.
scalability.
Okay.
Yep.
That's the one.
Thank you.
And we originally said 15. If you can do it in 12, or that would be hugely appreciated.
Do in 22 if that's fine. Hello, Ignas Bagdonas, Equinix. Right, let's look a little bit into some practical experimentation with BGP-SEC. So if I operate an exchange, and if I would prefer to see what happens if the current global routing system is BGP-SEC end-to-end. Next slide, please. So this is an experiment. This is a simulated playground based on real-world data. Based on the real world data for gathering the both absolute numbers and related relative numbers of all sorts of identifiers, paths, lengths, distribution of prefixes, and so on. This was done as an instrumented implementation for focusing with the measurement of the performance, and mostly into the right. I'll split this with. I will try to. Mostly for measuring the performance and trying to get some data why things work in the way they work, and why we are getting such performance measurements. This is a limited domain isolated environment which uses not necessarily what BGP specifies right now in the RFC. It was implemented as friendly to the environment in the sense that using vendor-specific code points, so there are no hijacks and other negative impacts. And the main concern or the main goal of this is to try to find out how this would work if we move to BGP-SEC end-to-end, and why it doesn't work as it is expected. Next slide, please.
And if you can speak even closer to the mic.
Right.
Apparently it's...
I'll try. Next slide, please. So if we use plain BGP, the setup of 400 neighbors, having some having full views, some having less than full views, with the distribution taken based on the public available route collectors. So 400 neighbors feeding into the route server, and then no policy, just best path selection. Everything is fed back. BGP does that in a minute and a half. For BGP-SEC, for exactly the same topology, it takes over half an hour. That's not necessarily the nicest result. Let's look why. Next slide, please. This doesn't run in a vacuum. It runs on specific hardware platforms, and those put certain limitations onto how things operate there. It's one thing to write an abstract code for illustratory purposes. The other thing is to write a code which runs on real hardware. And your contemporary compute platform has plenty of raw compute capacity as such. It might have plenty of memory capacity, but not necessary memory bandwidth, and memory latency is certainly an aspect to keep an eye on. Vectorization and SIMD wide operations are a general trend, and the increase in scalar platform capacity is low single-digit percent, whereas the increase in width of the computation is in orders, sometimes orders of magnitude. And yes, your fancy shiny platform can still run 16-bit code from 40 years ago. That just does not mean that it is the right thing to do. Sadly, many textbooks still continue to think that that is a reality. Next slide, please. If we look at the inners of a BGP-SEC, two steps. Receive things, hash the incoming parts, get the message to be signed, sign it. In this case, for receive, it's verify, and then do the rest of processing. SHA-2 is hardware friendly, and in general, that's a light, computationally light operation. Operates on a fixed blocks of 4 bytes and does a rather light arithmetical operations, shifts bit back and forth, and so on. The problem is that it touches memory, and touching memory is expensive. If you can avoid touching memory without real need, you better do that. Signature generation, it involves much heavier computational operations, large integer realization, plus there is also multiplication, and computationally it's more expensive, but it doesn't need to touch the memory. Therefore, overall, the longer the assigned path is, the more time you spend on calculating the hash, and even before that, fighting with the memory layout. And only then you do signing and verification in this case. Next slide, please. What is this vectorization thing about? That's a simple idea that you have one set of instructions, but you operate on multiple streams of independent data at the same time. This is a perfect fit into hashing multiple secure path segments, calculating and verifying multiple signatures at the same time. The operations for each SHA-2 block, they are the same, just the data differs. So take the full received secure path elements, feed them sequentially into different lanes for processing, and run SHA-2 transform on them in parallel. Works definitely works fine, provided that you can get your data into the layout that is friendly for this. Then once you have calculated the hashes, feed them into your elliptic curve stuff, and on the output you get the answer valid, not valid. Overall, the latency is marginally higher for this. You need to do some additional work, and some instructions are not directly one-to-one mapped as in a scalar world. But from the overall throughput perspective, you have performance increase proportional to the width of the vector lanes. Next slide, please. That's an interesting font over here.
Let's try that again.
All right. So the problem with not the font, but with the more important things is that the format of the secure path message on the wire is completely not the one as is expected for the hashing function to operate on. There are two components in the secure path, the path part and the signature path. The total length of the signature for the hop is 100 bytes, but that's 6 plus 94. None of those two, they are divisible by 4. And if you try to use the capabilities of your underlying platform, which is able to fetch only at 4 or 8 byte granularity, you cannot use this. You can force it, but the end result is that you will lose far more than the potential gain out of all of this. Therefore, the receive side problem for BGP-SEC is that it has data on a wire which directly contradicts to performant to have being able to have a performant implementation. Let's move to the next slide and see what the font we get there. Oh, the real one. For the transmit side, um, BGP-SEC signs also the target AS number. That's a good thing. The not so good thing is how exactly that is done. So if I advertise the same path and the same prefix to a multitude of neighbors, the stable part is the path itself and the prefix. What changes is the target AS number, the initial first 4 bytes, which are at the beginning of the block to be hashed. That means that starting from the first round of SH2 processing, the result will be different. And basically, we'll end up needing to redo all the calculation just for nothing. If instead that target AS number were at the back, the stable part can be pre-computed and the intermediate state cached. And the longer the path length is, the higher the savings in this case would be. The other aspects are exactly the same. Signature generation is computational expensive. It doesn't touch memory, therefore it's not of the big problem. Next slide, please. Back to the experiments. So do some fixing here and there, rearrange some fields, do some other protocol level changes, and call it a magic. And this can move into the order of 5 minutes for the same test environment overall. Next slide. So does this mean that BGP-SEC is fundamentally broken? No, it's not fundamentally broken. Everything is fine with the security aspects, just that the current approaches to the wire format and some protocol mechanics does not correlate well with implementing those things in a performant way. And it also is a little bit disconnected from the realities of the current compute platforms. Next slide, please. All right, that's actually strong encryption even for me. I don't remember what was written there.
Just when you get when I don't test you.
So I think those were the questions about those questions which you wanted to ask, but you didn't manage to run to the mic. So is this purely an implementation aspect? Can a smart compiler fix all of this for me? We are talking about the data dependencies, not control flow dependencies. Smart compiler is good at doing rather trivial things. For example, auto-vectorizing the round of SHA-2 is mostly feasible. You need just to provide a little bit help to the compiler. But certainly the compiler cannot do anything about on-the-wire data layout formats and overall the data architecture of your application. So if we use a fancy programming language, will this solve a problem automatically? Well, if you re-implement your BGP-SEC implementation in JavaScript, I'm not certain I can read it from that far. Thank you so much. What can be done then? I will return to that. Thank you, Jared. So if I rely only on the language aspect, no, you can make things worse, but not necessarily better. So what can be done of trying to fix the BGP-SEC here? First thing, the protocol is versioned. Warren, if you could try moving to the next slide, maybe it will work. No, it doesn't. So I will have to repeat that. So BGP-SEC is versioned. Now, right now we have mostly global deployment of 0 instances of BGP-SEC version 0. And if we define a new wire format, which changes a few of the things. First is how wire message is laid out on the wire, that it is one consecutive block and not intermixed fragments. The second thing, the algorithm identifiers right now, they define only the actual algorithms. They possibly could also identify the format of the message to be hashed and possibly processed in other ways. That would allow for certain degree of freedom of experimentation further, and making that in a more or less forward compatible way, as much as we would need that. Questions? So that was discussed previously. Next slide, please, and let's see what we get in discussion. Right. So that's a feedback of trying to experiment of what it would take for BGPsec to be deployed and used. The question is, do we as a community care about that? And if we care, how we try to address this? And that's it from my side.
And while we're checking if there are any questions, I'd just like to thank Ignis for having kept this short. Thank you.
Thanks.
There must be at least some questions. If not, we can also take them on list. Keep it short. And one from Sriram. Sriram, go ahead.
Oh, okay. Question. Ignis, we did some studies with like caching the signatures that have been already verified. So during the signature verification on the update, you can cache segments of the AS path, the signatures that you have verified, and next time the same update or another update that has a common AS path segment with the previous one, you can make use of the cache. So that's another way of improving the performance. Perhaps you have thought of it.
Yes, I do. This actually is contrary to the recommended practices of using elliptic curve signatures. You can do this only if your random number is stable and that leaks your key. That's not the right thing to do at all. Caching is certainly possible, and rearranging a little bit, a few things here and there you can cache, and that's the whole point. However, signature signing and verification for AS path longer than, in this particular instance, 4 or 5 hops becomes less computationally expensive than calculating the hash, and that is the problem. So you are not limited by the performance of the elliptic curve as such. You are limited by the overall performance of memory system.
Okay, thank you.
Yep.
Job Snyders, Fastly. You ask, do we care? I can indicate, just like in IEPG, I do care. And I do think that now is a good time to start work on this. I think version 0 will give us valuable operational feedback on how it works in the wild, provided that BGPsec router key publication becomes easily accessible to operators. And from there, migrating to a performance enhanced version seems a very logical and organic way to further the development of this protocol. So awesome presentation. Thank you for sharing your insights. And yes, let's do it.
All right. Thank you.
Thank you.
So I'm done. Thanks.
And next we have Sriram. And the slide deck is called Asper. That's got to be the one. Thank you, Sriram. Go ahead.
Thank you, Warren. So this talk is about ASPA verification procedures. We have considered some enhancements and also route server. There has been a very good, productive, creative discussion on the mailing list. I'm very thankful to Nick Hilliard for offering several very constructive comments. I've had discussions about this in the past with Alexander, and also thanks to Ben, Jacob, Shunwan, and Jeff and others for participating in the discussions on the list. Next slide, please. So we'll first look at summarize the working group discussions on the list, and based on that, we will look at a solution for the route server issue. There has been prior work where we identified a shortcoming in the ASPA downstream procedure that was presented a year ago at IETF 110. Based on that, there was working group consensus around that to update the algorithms to overcome that shortcoming. So in today, later on, I will describe the updated algorithms as they stand today. That includes the above fix from IETF 110. It includes the route server being properly accommodated. It takes care of some necessary special and corner cases. And it's ready for, the algorithm description is ready for updating the ASPA draft. Next slide. So I'm showing here a couple of URLs for the working group discussion threads. Next slide. So just few basics about the route server. RS is a route server in this picture, AS2. It's an IXP. RS clients are AS1 and AS3. So in the control plane, the transparent RS would insert its ASN in the path, and that is common. And the non-transparent RS, it would not insert its ASN in the, it inserts its ASN in the path. The transparent one doesn't. But the non-transparent RS is a rarity or even an abnormality. As you will see, we are not focusing the solution on the non-transparent RS. Instead, we are focusing the solution on transparent RS. In the data plane, the route server passes the next hop attribute unmodified to its RS clients. So the data plane connection between RS clients is a direct connection. RS client to RS is essentially like a customer to provider relationship. And the relationship between RS clients, AS1 and AS3 in this example, is effectively a lateral peering relationship. Next slide, please. So for ASPA-based route leak detection involving the route servers, we solved the problem for transparent RS, and it just so happens that the solution for the non-transparent RS comes with it at no extra effort involved. Next slide, please. So this is an example of like how, like it's a preview of the general solution with an example. The RS client, essentially, we recommend that it should include the RS ASN in its ASPA. So in this topology, the update propagates from AS1 to AS4 from left to right. And along the way at AS2, it passes through an RS. AS4 doesn't know that there is an RS in the path, and it doesn't need to know it. The ASPAs take care of that. So the ASPAs that for AS4 to validate the update and determine whether it is a route leak or not, the ASPAs that should be in place are the three that I show in the middle. AS1 attests AS2 as a provider. AS3 attests AS2 as a provider. So both RS clients essentially attest the RS as a provider. And in addition to that, the RS itself signs AS0 ASPA, and this recommendation is already in the draft. So with this set of ASPAs, whether AS3 receives a route, whether it receives the update with the RS-AS included or not, in both cases, in other words, whether it is transparent RS or non-transparent RS, in both cases, the AS4 is able to correctly validate and tell. In this case, it's a leak. So by having this set of ASPAs in place, the correct detection and the correct operation of the validation procedure is possible. Next slide, please. So the solution description is that each RS client registers ASPA, including the RS ASN in the SPAs. SPAs stands for set of provider ASS. In theory, it is sufficient that each RS client has an ASPA, just including the ASNs of its providers. other than the RS. However, some RS clients may not have any provider. So in that case, it's good to have a general recommendation that the RS clients should include the RS-ASN in the ASPA. And additionally, including the RS-ASN in the SPAs has diagnostic value for troubleshooting, etc. Next slide. So another thing that is currently in the draft in section 5.3 is that the RS client detects whether the RS it is connected to is transparent or non-transparent. And based on that, it applies either the upstream algorithm or the downstream algorithm. However, Nick Hilliard offered this good suggestion based on which we don't have to do that. That complication can be avoided. And the way it is done is that the validating AS, if it has the RS client role, it determines whether the most recently added ASN in the AS path equals the sender's AS number. In this case, the sender is the route server. If that is not so, that is a confirmation that the RS is transparent. In that case, the RS client can simply add the RS ASN to the AS path for ASPA verification purposes only, and then the downstream verification procedure can be applied. So there is no need to make a choice at the RS client between the upstream procedure or the downstream procedure. So with this modification or simplification, the section 5.3 in the draft can be potentially deleted. Next slide, please. So now quickly, the refined enhanced ASPA upstream and downstream verification procedures, including the enhancements, including the fix from IETF 110, as well as, next slide, please. As well as some special cases pertaining to presence of AS set. That's already in the draft, but some special cases that have to do with the length of the update, etc. One can simplify. I mean, one can additionally enhance the procedures. So that's been done, and I have shared with Alexander a few times, and we didn't get a chance to spend too much time on it, but we did, Alexander did look at it, and I have some feedback from him. So in terms of the description, this is complete, and it includes a number of corner cases that are necessary. It includes the treatment of the route server, as we just discussed a few slides ago. Next slide, please. So downstream procedure is described in these two slides, and it kind of takes care of various corner cases, special cases, the route server, as I said, and we have confidence that this works. Several people back in 1 year ago, people reviewed it, and we have confidence that this is a good way to update the algorithm. Next slide, please. So similarly, the upstream has also been enhanced, including the special cases. Again, I'll not go through these stepwise, obviously, but the description is complete, and we can take one more look at it, and potentially it's a good candidate to, at least in its the form. I mean, the wording may be different, but essentially all the necessary ingredients for the procedures are described here. So it should work pretty good to update the draft. Next slide, please. So at NIST, we have been working on implementation of everything, BGP ROV, BGP SEC, and we have those implementations available in BGP SRX. And included in that is also the ASPA procedures that are described here, except for the route server related parts, which are new. So this is the reference to our implementation. There is also data that is available for tests. Data sets are available for testing. So that concludes my presentation. Thank you. Happy to take questions.
Excellent. Thank you. We have Ben and Alexander, and thank you again for doing it in a short time, and thanks to everyone for keeping questions short.
Hi, Sharon. I'm a little confused by the root server handling. Warren, would you mind going back to the example topology? There's the one further on where it had AS4 in it as well. That's the one. I'm a little unclear still as to what we thought was broken prior to this update. There is no difference from the perspective of AS4. If the RS is a transparent one, it can be ignored altogether. And if it's a non-transparent one, then it is indistinguishable from a transit provider. All that needs to happen in order for AS4 to correctly detect this as a leak is AS1 needs to have created some ASPA with any contents as long as it doesn't have AS3 in it. And that's what the previous version of the algorithm said. I find the additional corner case is a complication rather than a simplification, and I don't see the logic personally.
Yeah, if you thank you for the question. If you focus on like here we are looking at AS3 from AS4. From AS4 points of view, what you said is correct. It doesn't need to know about the presence of the RS, whether it is transparent or not. All that it needs are the ASPAs that the two RS clients should have with any ASN, whatever, any provider that it may show in the ASPA. But if you look at it from the point of view of AS3, when AS3 RS client is validating AS, then it helps for it to see that AS1 has registered an ASPA, including the RS ASN in it. And that is one reason so it is not necessary to include the RS ASN in the ASPA, like you said, because we are already assuming that the non-transparent RS is a rarity. However, if in cases when the RS is non-transparent or even otherwise, it helps the RS client. So AS4 it doesn't matter, but for the RS client AS3 it matters to some extent to have the ASN of the RS in the ASPA.
Thanks, Aaron. I understand the explanation. I think it's important to realize that AS3 knows that it's speaking to a root server.
It knows, yeah.
I don't think that having corner cases in the protocol helps anyone here. I think it's more complication, and the validation that AS3 applies can take into account its local knowledge. I think this makes the validation procedure harder to understand rather than easier.
Yeah, let's take that beyond the list. Yeah.
Let me try to jump and ask the question for Shiram. The problem occurs in a slightly different topology. Imagine on this drawing that IS4 is a customer, and it receives a prefix from IS3. And in this case, if IS1 and IS3 haven't signed the IS2 as its provider, it will treat such a route as a routelet. So one hop away from the transparent internet exchange point, we cannot distinguish if it is a routelet or if it is not transparent internet exchange point. That's the problem. And
Alexander, are you talking about the case where the IXP root server is non-transparent there, yeah?
Yes. And a slightly different drawing where IS4 is a customer of IS3.
I understand. So I think in that case, in that case we embrace the fact that the root server is a transit provider. It is a transit provider. It's just not giving anyone a full table. And I think we should embrace that rather than trying to make them artificially into different things.
Yeah, I totally agree with you. And so in this direction, I had a plan to change the document. I'm
Yeah.
sorry for interrupting.
No problem. Thank you, Alexander. I just want to add to what you already said. I think you said it correctly that for the non-transparent case, if it may be extremely rare, but just in case the route server inserts its AS number, and for example, AS4 is a customer, as you said, in order to be able to detect route leaks, it is not a corner case. It becomes useful for the RS client to include the RSASN in the ASPA. I think you agree with that.
Okay, thank you. I suspect there'll be some more discussion on this on list.
Yeah, I'm sorry, Warren. Yeah, I would request Ben to put a message on the side on the list so we can understand if we misunderstood him.
Thank you. And Ben says he'll put it on the list.
Okay,
Excellent.
great.
Thank you. And we seem to be managing to recover some of our time, but we will still try and make sure that we get through things so everybody has a fair shot at the mic. And I believe next we have Job, RPKI, and CT and Discovery. And I think this is 15 as well.
All right, I'm back, Job Snyders, and I'm here to steer up some stuff and cause us a lot of work in the next 5 years. This is an attempt to kick off a what I would say is quite large project amongst our fairly small community, but I do believe it is worthwhile. And in this deck, I'll try to explain why. Next slide, please. So if we look at the RPKI, although the standards are 10 plus years, it's only in recent years that we've really grown through some teething pain. I think this image is a bit of a joke, but we've come a long way in the last 2 years. I know that almost all RARs are now testing with multiple validator implementations before pushing code to production. Some RARs even move to a 24/7 support model. I think RP implementers have taken a much closer look at the original intentions of the design behind the RPKI data structures. And also, for instance, on the BGP router side, a few terrible bugs were uncovered and subsequently fixed. So, we learn as we do. But there is more. Next slide, please. Because if I look at our sibling, the web PKI, they are years ahead of what we are doing. And I think they're really cool, and I would like to copy some of their ideas and apply them to the RPKI for mutual benefits. Next slide, please. All right, let me go to my backup copy of the slides.
There we go.
So this slide shows some differences between RPKI and WebPKI. In the WebPKI, if you want to be a root CA, synonymous to the trust anchor operators in the RPKI, there's a number of things that happen in that ecosystem that we sort of skipped over or are now slowly catching up to in the RPKI ecosystem. So for instance, if you want to operate a WebPKI CA route, you have to jump through many hoops to produce audit reports and share those audit reports with others for review. You might be operating your route for multiple years without any subscribers. So the analogy to the RPKI would be without any subordinate INR holders before you are included in commonly accepted trust stores. and that's kind of the paperwork side of things, I would say, because an audit report and then a compliance report or running for years in a sort of dry mode is an administrative action. But to help justify the trust in a roots in the web PKI, there's an additional technology that is used, that is certificate transparency. So audit reports are for the bean counter, so to speak. Certificate transparency is there for computer geeks to verify if what is happening under that root actually happened. Next slide, please. This is not getting any better.
There we go.
So this slide contains a pointer to the last RIPE routing working group, where Martin Hutchinson from Google gave a very high-level introduction to what certificate transparency is, what the benefits are, and some pointers to how not just the web PKI, but also other PKI infrastructures are leveraging certificate transparency. So reviewing the 20-minute video is worth your time. Next slide, please. Nice. So in order to kick off a certificate transparency project in context of RPKI, we need to map certain concepts from the web PKI to the RPKI and use that to develop our own procedures, to make extensions to our own software. So in the certificate transparency world, there's a role called the believer. And the believer is an entity that takes an attestation made by a claimant and verifies that according to the cryptographic procedures as described in the specifications. So in the web PKI world, the believer is the web browser. And in the RPKI world, the believer is the relying party cache implementation. So the likes of RPKI client, Fort, or Routinator. Verifiers are entities that have a stake in the ecosystem. And in the web PKI, this could be the owner of a domain name, say fastly.com. In the RPKI, this is the resource holder, so the holder of an AS number or a set of IP addresses. And the verifiers want to know what certificates were issued covering my resource or my domain name, which means they can verify whether it's CAs exist which hold those resources as subordinate, whether they are all under control of the verifier, but also security researchers can assume the role of verifiers to compare what they see in the wild versus what should exist. Then finally, the claimant is the entity making attestations about who issue certificates. So in the web PKI, we call them CAs, but in the RPKI, it's basically the trust anchor operator plus the CAs that belong to the trust anchor operator. So in the RPKI, you have the trust anchor itself, which is usually the offline HSM, and a few intermediate certificates that hold the power for 0/0 in both v4 and v6. And then the trust arc jumps towards the CAs that are heavily constrained by the 3779 extensions. So in the claimant, for the purpose of this presentation, is kind of the top of the trust tree. If you follow this link, you can read more about the use of these words. Next slide, please. Now, a very natural question is, why not use existing publication mechanisms like rsync or RRDP? And we have to realize that both rsync and RRDP have been optimized for a very specific purpose, which is to bring the current set of objects as fast as possible to a verifier, to, for instance, the RP implementations. So an example of why RRDP might not be complete is you can, although everybody knows that manifest numbers monotonically increase, between RRDP deltas, you can observe in some situations gaps in that numbering scheme. Because if a user adds a ROA and deletes a ROA in a matter of seconds, the subsequent event overtakes the earlier event, and it's not worth sending out the earlier manifest because it has been overtaken by events. And the purpose of certificate transparency in this regard is to provide full insight into all CA certs that have been issued, which makes it a bit of a heavier machine. And therefore, I think it's very good to have separate mechanisms, one targeted to get files or objects very fast to the verifiers, to the believers, apologies, and then a secondary system that is designed to inform verifiers about all actions that transpired. Next slide, please. So the benefit to the community is that if we set up some kind of global RPKI certificate transparency system, we get auditable logs of all actions that RARs took. And this means that resource holders, such as myself, can inspect exactly which cryptographic entities at what point in time had received what entitlements. So in the case of, for instance, RSC, it's really nice to understand at what point in time could anyone other than myself and my parents issue RSCs signed with my resources. Or if there was some kind of administrative issue where for one reason or another my RPKI entitlements were revoked, when exactly was my ability to sign with those resources reinstated? And I think that having this type of maximum granularity or full detail, like the highest resolution image that we can get of the issuance process of the RARs, will positively raise the bar in the ecosystem. So aspiring to implement certificate transparency forces people to take a careful look at their issuance process and document and understand how exactly their procedures work. And through that process, we may see some organizations optimize their process. So I think it's good to have something on the horizon that yes, is difficult, is not cheap. It will involve many man hours or people hours. But the end result is, I think, a healthier ecosystem that is worthy of the trust of the believers. I don't think it's, I think it's not sufficient to say, hey, we are an RAR, you can trust our brand, we are trustworthy because we engage with the community, we listen to you. All of this is true. But in addition to that, I want to be able to audit those claims and see what the health status of a trust anchor operator truly is. Because that provides the grounds to engage in conversation and make retrospectives on incidents and talk about why did this happen and what can we do to prevent this next time. In the same way, I see that CT in the web PKI has brought numerous improvements and far more disciplined operation of the CAs in the web PKI, to the point that now CT and the web PKI are so intertwined that web PKI is fairly functional these days. So next slide, please.
Last slide's broken.
Uh,
But it's here if you want to see it in the big screen.
well, you can see my slide here. So the to-do list, and keep in mind this is a multi-year project. So if you happen to be an RER and you look at your budget and you're like, there's no way I can pull this off, that's okay. There's always next year or the year after. This is not a project we should rush through. This is a project where we should carefully take our time to establish what exactly it is we want to implement. So for the initial scope of certificate transparency, I propose that we attempt to keep track of the CAs in the ecosystem. So we leave ROAS, GBRs, BGP-SEC keys, ASPA objects out of scope. Those are EE certificates. I think if we can get to the point where CA certificates are carefully tracked, that would also already be a big step forward. Now, who does this concern? As I mentioned, I think the RARs are the ones, the prime candidates to provide a high level of transparency through CT. Log operators, some entities will need to set up services that can absorb information coming from the RARs and publish that in immutable logs. And then, of course, verifiers. And that could be anybody with a stake or interest. So somewhat out of scope is delegated RPKI or even RP implementations, because RP implementations are just believers. And then the second part of my slide is a call to look for interested people. Step one would be to offer an internet draft that kind of maps out a plan about what CT is and how it applies to RPKI. We need to find people that are willing to host logs, because the claimant should be a different, the log operator should be a different entity than the claimant. We need to find people that are willing to send pre-certificates to the logs, and ideally find people who have hands-on experience with CT and can help our community understand what to do and what pitfalls to avoid. So with that, the microphone queue, I guess, is open.
Yep, and we only have 5 minutes for questions, so people can keep them short. 1 minute each.
Okay, Ties de Kok. Yeah, I like the idea of CT, and I see a lot of value in applying certificate transparency when you apply this to entity certificates, like the resource signed checklist that you mentioned, because it's very hard to observe all the objects and to know what was actually published. And unless you have certificate transparency on entity certificates, you cannot show a very important attack in the RPKI, which I think is the omission of objects from the view that you present to somebody. And for that will be critical that EEs are included initially. But my main question is...
If I may respond to that.
Okay.
It would be very cool if EE certs can be part of the CT log infrastructure. And I'm not precluding or I'm not excluding that path, but to reduce the scope and get somewhere, I think it's great to start with CAs. And if we can get that working, we can maybe add more to it.
Okay, I don't see much benefit in removing the code path where for a CA certificate you submit it to the log, incorporate the RSC, and for a EE certificate you don't. But that's we probably actually have to prototype this to see how it works out. But if you want the RPs to check certificate transparency, they will need to check the attestations that are in the CA certificates. This means that when you want to create a CA certificate, you need to get enough responses from qualified logs, at least in the web context. And that implies that log availability causes an upper bound on CA availability. And more brittleness in the RPKI scares me a lot, being an actual CA operator of a real world instance that has a lot of impact. So how do you think about this risk?
So as you can see, clearly, I consider RP implementations at this point in time out of scope because RPs are believers and they just absorb RDP and rsync and do what they do today. Separately, we'll create verifiers, maybe based on existing RP code bases, and those would absorb the logs and maybe use emit monitoring alerts or but an RP in the RPKI context is a believer, not a verifier.
So sorry, we are going to have to move
Okay,
on
then
to
we
the
need to
next.
clarify the work on the chat model.
There's lots of clarifications that need to take place. I don't consider myself a CT expert either, so we'll need to educate each other. And yeah, that means lots of talking.
Koen van Hoven. In WebPKI, the end game of certificate transparency, at least as I understand, is that if a CA really misbehaves, we just pull it from our trust and we don't longer trust the CA. What do you see as the end game for RPKI? Because I believe there is no real alternative to the RARs currently.
If an RAR misbehaves,
Yes.
I will remove them from my truster.
Okay, and is that also your goal with certificate transparency, to see if an RAR misbehaves and then to pull them from your truster?
The first goal is to engage with Rudiger. The first goal is to engage with the RAR and confirm with them, hey, I saw this incident, can you provide me with an RFO? And then an RFO appears and hopefully everybody learns. But if the same type of mistakes repeats over and over, or if there are systematic issues, it could motivate some operators to perhaps temporarily or perhaps permanently no longer cease using a specific trust anchor. So the goal of transparency is in part to be able to hold people or organizations accountable. But distrusting a root is then that's the end of the process. That is the death of the universe. So the goal of CT is to avoid to get to that state, because we can learn from what appears in the logs.
Okay, so it's just logging and knowing that it happens, but that's it, right? Then, or
the first step towards solving a problem is knowing there was a problem.
Okay, thank you.
Thank you. And next in the queue, we have Russ.
Hello, Russ.
So, I have real problems with this work. My concern is that the RPKI, unlike the web PKI, was constructed so that the CA is authoritative for the resources that it issues. The web PKI, on the other hand, all of the roots are able to do anything with any aspect of the namespace. So when we started working on this, the IAB suggested that IANA run a /0 and the RIRs be subordinate, and then to accommodate easier transfers among the RIRs, each of them became equal roots for /0. I argue that you don't need this if you go back to the first model.
Thank you for your comment, Russ. I think I should clarify and probably repeat this at many subsequent presentations. In the RPKI ecosystem, there are 22,000 CAs. The ones to which I think certificate transparency applies are the RARs that have the 0/0 certificates and their intermediate operational certificates. And the moment the trust arc bounces towards, say, an LAR, who indeed are heavily constrained by RFC 3779 extensions, they can only shoot themselves in the foot. So I want to know which other LARs are able to sign with my resources, but beyond that, I'm less interested. So I think in practice, in the RPKI ecosystem, CT will apply to maybe 15, 25 CAs, but the CAs that I myself as resource holder run are not of interest to the CT project.
And we're really going to have to keep the questions and answers a lot shorter. It's been way more than 15 and we're
okay. Well, two views. One is following Russ. Some of the basics of web PKI and VR PKI are really different. For some parts of your arguments, I had the bells ringing, for example, that you should keep in mind that CA and identity are not really the same thing. So kind of harking back to successful treating web PKI is not necessarily the most valid thing to do. Nevertheless, the activity of establishing tracking mechanisms and monitoring for what is in the RPKI and figuring out what information support should be generated. Like your question, I am the holder of resources, and for a long time, I have been thinking we need to establish some monitoring and things like that, including making it easy for resource holders to get an independent signaling of what the global view of their resources is. So for many of the details, I think the web PKI is directing you to bad tracks. The idea of we want to monitor this and figure out a lot of details, what is necessary and useful there, that is valid work. And well, okay, that's so I don't want to dismiss this effort overall, but I don't think it is headed in the right direction right now.
Okay, couple of things. I'm not sure that either of them are really questions. So the first is, I think we need to do better as a group about distinguishing when we're talking about publication events versus signing events, because often, obviously they happen very close together in time and usually by related parties. This is for me, about seeing signing events which are not visible through any theoretical version of the publication system, not just the one we have now. I think we probably want something like this for the publication system as well, but they're separate problems. And I think, Teeth, for example, the problem that you were pointing to, that's an important thing that I want to be able to see, but that's not a signing event that I'm looking for. That's a publication event that I'm looking for. Anyway, afterwards. The second thing that I think it's important to point out is I have a very good working relationship with my local RIR. I know the individuals involved. I trust that they are doing things with the right intent and are not trying to, act with any malfeasance. But that's not necessarily where the chain of trust needs to stop. I also need to be able to demonstrate to some third party when the RPKI eventually causes some substantial outage for one of my customers, when it will, it's just a matter of how and when and what that looks like. I need to be able to stand up in front of those people and demonstrate why it was reasonable for me to trust this system in the first place. And having things like some version of CT, having the ability to demonstrate that the publication system was sound, all of that sort of thing allows me to make that argument better and allows me to use this in a more robust fashion.
Thanks. So email me if you're interested in this type of work. And this is super early stages. No direction has yet been set, other than I want more transparency in this ecosystem. Thank you.
Excellent. Thank you very much. And now we have our last presentation. And thank you.
So, yeah, I think we are a bit short on time, so I will try to keep it short. So my name is Koen van Hoven. I want to talk a bit about the RPKI off the beaten happy path. We know how the RPKI works when everything works, because it currently does. However, there are a couple of edge cases that can currently occur with the current standards, which would probably be cause some issues. And I want to discuss 5 of them and basically ask your input about what you think should happen in these cases. Next slide, please. The first one is partial RPKI data. The ID is, now this is a fictional example, however you can find similar examples in real life. We have a CA0 at the top, and it has 3 children. CA1, which has a ROA for 1.100616. We have CA2 for that has it for the /8, another one for the /16, and CA3 for and CA4 below CA3 for /24. Uh, the problem is that if you for some reason CA3, for example, becomes unavailable, then you have a ROA for the /8, and you don't have it for the /16 that is a subset of the /8. And now you get a valid that becomes invalid, which is contradictory to the fail open situation that we normally have with the RPKI. And the question, of course, then is, well, what do you do? Do you then include the data from CA2? Do you use the cached version if you have it from CA3? Do you and what do you do with the data from CA4 if that's a child of CA3? Or do you just say, okay, if you're doing this, then you're so stupid, then this is your own fault if anything bad happens? And then the question that, of course, also you get is, when do you actually, and when should the relying party actually report ready to RTR that it has tried to get all the data and perhaps failed for CA3? Next slide, please. Now, a couple of ways that you could have situations where you don't get all the data. Look, I can delegate my resources, and I can do that as however I want. So if I'm E in this case, I can create 9 children that are all different publication points and different locations. And they can also delegate their resources however they like. So they can delegate it to 9 children again. And we can do this for 8 layers. We have some limits to the depth of the chain. This is based mainly implementation. This is not, but not in the specification. However, if just already with the limitation that we currently have, I can create in the end 5 million publication points just by creating something that is 9 wide and 8 deep. And the question that I have then is what should the RP software and operator do in this case? And should the CA prevent that from happening, or what should the CA actually do? And also, if you think that you notice something like this, but it is actually just an honest structure that looks strange, how do you then deal with false positives? Next slide, please. There's also something about file systems. I mean, this is all runs on machines that have actually that just have actual disks. Especially with rsync, we first get the data and then we do something with the data. Now, we have some ways to exclude files we don't like, and those are being used, but we can create many folders. And the thing is that we can even do this, well, not just the publication points can do this, but any hop between us and the publication point can, for example, modify the reply that we get from rsync to add a lot of folders in between them. I've shown an example structure that you could use, and that means that if you were to apply that to the right NCC publication point from 2 months ago, then you would get about 18 billion folders, which is probably more folders than your file system is able to manage. And in the current implementations, what we see is that there is no way to restrict it in any way, shape, or form, which then means that your file system says, okay, I cannot handle this anymore. And whatever happens is then left to what your RP implementation does and operating system. But it definitely really doesn't result in you having actually data that you can use. Next slide, please. And this is also very simple, but we have ROAS and we can create ROAS. So if I was just calculating, okay, how many VRPs can I create from my ROAS? So I mean, let's say that I have a slash 48, which is not that's out of the realm of possibilities. Then I can create 2 to the power 81, give or take, prefix from that, because I can split everything up into everything, which is not useful in any way, but I can. And then I can allow that for 2 to the power 33 ASNs, which means that you get a very large number of possible VRPs that your router is probably not going to handle. However, RPs accept this in principle, RTR accepts this in principle. So at which stage should we actually go, okay, probably not don't need all this data, we should probably leave something out. Should the router do that, or should the RT do that, or your relying party should do that, or the publication point, or the CA? Next slide, please. So, and then the last thing is, if something like this happens, and I just do this because I very, very much dislike you, then I can do this and only target you. Okay, if we do then get significant transparency, this becomes a lot more difficult for everything that requires signed objects. But the rsync one, that can also be done as a man in the middle, so, and you would stay out of the significant transparency part. So my question then is, okay, how can I effectively stop this? And if I cannot stop it, how can I report it to someone else that can stop it? And how can I prove to this person that or this organization that actually this is happening, and I'm not just making this up because I want to get someone else taken down that is actually the one that I actually dislike. I mean, there are malicious parties out in the world. I would rather like it that there weren't, but they just are. And so the question for that is, how can I prove who the perpetrator was, and is that even possible? And how can a CA know that what they are doing actually is viewed by me as something that is malicious? Next slide, please. So those are the 5 points that I wanted to discuss. And my question to you is, should these problems, or if there are problems, be dealt with? And if so, how? Who should solve what? And if they're going to be solved, should that be done in a proactive manner or in a reactive manner? So I would like to open the floor and or the microphones to your comments.
Thank you. Jobs first.
Job Snyders, Fastly, OpenBSD. I don't want to go slide through slide to offer potential solutions or answers, but for instance, I think that publish in parent really is a technique that helps the whole ecosystem. Because one of the fears is that a sibling CA of yours can do something that somehow knocks you out. And for instance, in the partial RPKI data example, you listed that if CA3 has an issue, CA4 disappears. A lot of those scenarios are alleviated if publish in parent is used. And I think for this reason and other reasons, we as ecosystem should really strive to get rid of not get rid of the delegated aspect, but encourage everybody that the default setting is publishing your parent because it makes life easier. And if you publish in the parent can out of band, so on the layer where the child is sending it to the parent's API, apply some restrictions. Like with email, in the SMTP protocol, it's not encoded that I can only send you up to 10 megabytes. But if I try to send you a 10 megabyte email, your email server will say, oh, it's too large. I'm not eating this. Another mail server might happily accept it. And this is local policy. So each parent repository can apply local policy as is appropriate for that context, that environment, without signaling such limits through the RPKI. So the parents, I think, can not only help RPs and help against partial RPKI data, but also keep their children in check in a way that is lightweight, dynamically adaptable and does not encumber the broader ecosystem. But I can monologue here for hours. I yield the mic to other people.
Yes, thank you, Job. I think you make a good point. However, that implies that you get a first-class citizen, namely, or the first-class publishing parent, and a second-class delegate. And I'm not. It is a solution, but I think that is a consequence of that solution that needs to be, at least people need to be aware of.
Right. Yeah. Tim Ruijsels, Nelda Labs. My name was on the first page of the slide deck. One thing I wanted to say first is I think this is an example of a number of issues that may occur and a general question about how we should deal with them. Secondly, to be a bit more specific, my feeling is that there are things to be discussed. With regards to these suggestions that Job just made, I think there may be work there, but the current reality is that parent CAs can only be reactive. They can stop a delegated CA when problems occur. But I think we should look into more proactive measures. And if we want to do things with repositories, that implies that we need to look at the publication protocol. That also implies that we may want to think about what trusted repositories are and whatnot. So I think those are all very interesting things to think about. But currently, just to repeat, I think the reality is that we can only be reactive.
Thank you, Tim.
First, small side note, thinking about of bad characteristics of rsync, just ignore. Rsync has been identified as a danger spot and is being replaced. For the volumetric attacks that you were going, well, okay, I think they will blow up much earlier than they hit the routers. Well, okay, the thing that you really should be checking is your first slide, where you only told the ROAS that certain CAs are supposed to publish, and you did not show what resource sets the CAs were holding.
Mm-hmm.
And the trouble that you constructed depended on the unusual idea that the delegation of resources was not hierarchic and kind of overlapping between siblings. And yes, the monitoring and tracking system quite certainly should show that. And yes, the policies that this should not be done when running your registry have not been that obviously and formally raised, but they are actually, I think, very well understood.
Thank you, Rudiger. Yes, I want to point out that this was based on a real-life example, which is currently in the primarily APNIC and IDNIC relationship where this happens. It's not yet, it doesn't happen a lot, but it happens in some places, so that's why I
Yeah,
raised it.
that sounds like to rehark to Russ' remarks about having a single or multiple routes and not having very clear and explicit formal policies about how the resources managed under the overlapping routes actually are defined and tracked.
Thank you.
I'll try and keep it as short as possible. I think your first your first example may well have occurred in the wild, but I think it's an example of, you know, people will be able to shoot themselves in the head using whatever technology we give them. And that's, you know, that example is an accident waiting to happen. I think for the rest of this, I think that it's an important problem, and we do need to be clear about what the action we take is. I'm not convinced that any of the action that we take against the kind of the potential DOSes that exist should be changes to a protocol. What I do think that we need to do is being much clearer on, in particular, how RPs are dealing with placing limits on their willingness to traverse trees and lots of directories and lots of objects and so on and so forth. And it's not necessarily the case that they need to implement the same protections or make them as configurable as one another. But I think that there would be value both for people potentially doing new implementations or for information sharing between implementations or users of those implementations, if there was some collaboration between RP implementers to document what recognized attack vectors there are and how they each deal with them and the strategies that have been taken and the trade-offs. You know, and I think that wouldn't be you know, anything more than an informational document, but I think it would be a useful reference point. But I don't think that I don't think that constructing a system that is impossible to abuse or that is capable of, you know, not breaking under any, you know, absurdly overloaded circumstances available to us, because essentially the limit is your memory if you don't have anything written in the software. Yeah.
Thank you. Jared Mach, Job Q's Callist. One of the things I observed in listening to this is how much it reminds me of the early days of Usenet News, which was a case where you would have these files and they would get transmitted over this protocol, and you would write a whole bunch of directories and files out to the file system. And one of the companies that decided they wanted to build commercial software to run a Usenet News server, they actually figured out that leveraging the underlying operating system was actually inefficient. And while I know the original implementations of much of this used things like rsync as the method to go and transfer the data is still just data, and the files are just files. And that doesn't mean that an implementation shouldn't perhaps look at, okay, do we abstract this out and store it in our own internal data store? So, you know, what one of the companies did is they went and implemented a solution whereby which all that data was still there, but instead of them having to go out and making all of the file system calls and dealing with all of the slowness of interacting with the kernel and operating system and hardware, they actually implemented a lot of that internally in something that was optimized for that use case. And I suspect that historical perspective may be useful in the context of this, which is we have a lot of potential traversal stuff, a lot of potential file creation and stuff, and as well as expiry policies, which are very similar to, but not exactly identical to that use case. And the solution space may lie very similar to that software, which then became very dominant, even though it was commercial and there were other, you know, open source softwares to compete as a result. And so I think here that is very likely the case. You know, that we should be looking beyond the individual file systems and looking at how that actually data store is held in, you know, internally within the software and versus that. So I'm not sure what your thoughts are on that. Well, I think you are. I agree, and for RDP, a lot of implementations already do that. But the rsync protocol makes that more difficult to achieve that same. So I believe that there are implementations that do that for RDP, but do not do that for rsync at the moment, because rsync is still a requirement. So you can always downgrade to rsync and then execute the same attack.
Okay, and our last one. Thank you very much. We managed to recover some time.
So we had these initial reports about these issues, and we resolved part of these attack vectors, which is a really good step, because it got a lot more complicated to do a denial of service attack on all validators worldwide. However, you also showed that if you want to attack a specific instance, you can still do that, because it's really hard to set these limits in a way that in the recursive case, which still needs to be quite wide, because some CAs are quite wide. You cannot abuse it. So in my opinion, we need some work on that in this working group, so that at least relying party instances can detect it when the administrative domain changes when traversing the tree, because for some entities it may be logical that they have an extremely large repository, and for a non-RAR it's probably likely that their logical entity has an order of magnitude less objects in there. And yeah, I think we should continue investigating this issue.
Thank you, Ties. I think that was
Excellent.
it.
Was it?
I want to congratulate Warren for being the first one that has managed to voluntarily get a group of engineers to accept cookies. So congratulations to Warren.
Cute. So thank you everyone, and also thank you to the speakers and questioners for keeping things short. We did lose some time in the beginning, but I think we're going along nicely. And also thanks everyone for we're going to try to keep things civil, code of conduct, etc. Again, passion's great. Poking each other is not. So thank you everyone. And pardon? Oh, we can still be mean to Chris. Yeah, she's not here. Actually, I mean, yeah, we can joke at Chris. Okay, so I keep forgetting that I'm coming home tomorrow and you live nearby. And if you all don't hear from me on the list for a few weeks, somebody please come find me. Okay. Thank you, everybody. Thanks to the speakers. Sure. It seems to be something